video we are going to cover the topic known as the concept of accelerated vessels containing liquid. So first of all, before going into this, let us remember something, like remember/revision. Up till now we have studied the static fluid, and in this static fluid, when I say that okay, this is my static fluid, if I go from the free end to the downwards, there is a pressure increase of rho g h, and in the differential form we proved it as dp by dh, means this was dh, so dp by dh is equal to gamma minus gamma. And when we go in the horizontal direction for static fluid, remember this is all happening for static fluid, in the horizontal direction there is no pressure change, means dp is equal to 0, and when we go upwards in the same fluid, then dp is positive, right? Means dp increases. The pressure change between these 2 points is, if this is z, then the pressure change is rho g z. Okay, so this is all about the static fluid. But now let us take the same fluid filled container, this is the container, and say that okay, this container is on a truck mounted with rollers. Okay, and now this particular thing is moving in an upside plane with an acceleration. Now we have an acceleration in the upward direction, right? So a is a vector quantity, as we know, right? This a, if I consider this is the x direction and this is the y direction, this is the z direction, I can say that this is a. And if I reduce this into components, then component of a in the x direction will be what? Ax, and component of a in the z direction will be az. So now let us see this this particular vessel in the x direction. So this was the vessel. I am not drawing the rollers now. So this whole vessel was moving into acceleration of ax in the x direction. So if I take a point, it's a small point here, and magnify it, let us magnify it. So let's just say okay, there is a, let's just make it as a cylinder. We know for any part of a whole body, we take the we take the infinitesimally small strip. Let us take an infinitesimally small strip dx and try to see whether there is a change in this. So I'm moving from this point 1 to point 2. This all is happening at this point. So at this point, what is the pressure? We know the pressure is P into dA, and at this point, say and we are moving in the x direction. Okay, so we are not concerned about P into, let's just say that in the, as we move from this direction to this direction, the pressure increases. I am assuming that the pressure increases by dp, and if I multiply it with an area, then it will become a force. So force at 1 is 1 P into dA, and force at 2 is P plus dP into dA. I have considered that dP is the increase from point 1 to point 2 and when we finally if there is no pressure increase in from point 1 to point 2, then dp will come out to be 0, and this whole element was moving with an acceleration of ax in the x direction. So force analysis, if we do force analysis, means we'll just write the summation of all the forces in the x direction will be equal to, now this particular fluid is not static, so it will be say this whole element mass is dm, so mass into acceleration, force is equal to mass into acceleration, Newton's second law of motion. So mass into acceleration. Force in the x direction, if I consider obviously this, since acceleration is in this direction, so this will be considered as positive. So okay, p into dA is the force in the x direction, this one, then this minus sign is because it's in the opposite direction, so p plus dA, p into dA, and then dm into ax. This pda will get cancelled, so minus dp by dA equal to what we can write for dm. Mass is what? Density into small volume. Density will not be density is a constant quantity, so it will not change. However, for small mass there will be small volume, so rho dv into dx dp. This area is dA, as we know here from here, and the volume of this particular fluid element will be what? dA into dx. So rho dA into dx is into ax, so dA will get cancelled, and we can get dp by dx as minus of rho ax. Means the pressure, what it means? It means that the pressure in the x direction for a small change from point 1 to point 2 will be what? Will decrease. They are saying it will decrease. Okay, means you can also imagine it in a crude sense. Let's just say, let's imagine it this in a crude sense. Okay, so if this particular vessel is moving in this direction with an acceleration of ax, then what will happen? The water will be somewhat like this, because what the vessel will move front, but the water will try to remain stationary. So water at the at the farthermost point will try to go up, and the water level at the nearest will try to go down. This was the initial water level. Okay, so if I say that okay, this was my point 1 and this was my point 2, you can easily say that you can easily see that due to acceleration, the point 2 pressure and the point 1 pressure, this height h1 and this height h2, you can easily see that this height h1 is greater than h2, which means what? P1 will be greater than P2, which means what? Again, which means that once I go from P1 to P2, my pressure will decrease. And how much it will decrease? It will decrease by dp by dx. When I go an x distance of x, it will decrease by rho into dx. So this is my formula for in x direction, but it's not over, because the vector quantity, the acceleration was in the inclined direction, and we have solved it for ax. Now we have to solve it for ay. Then we will combine the two, and final expression of the change of pressure due to acceleration will come out. Okay, so this is say like 1. So now we will do the same analysis in the z direction. And remember, here we didn't take the dm into g, means weight of the element, because this was in the vertical direction and we were going in the x direction. So the same vessel containing liquid is now traveling with a acceleration of az in the z direction. So again I will take a point and I will try to solve it. So this is the cylinder. I am considering a cylinder. This is my point 1, this is my point 2. So generally when we go from point 1 to point 2 in a static fluid, we know that the pressure increases, right? The pressure increases from below to up, it increases by rho gh, from down to below it decreases by rho gh. But now it is accelerating, so something else might come out, so we'll do it. So first of all we'll try to say this area is dA. So force on point element 1 will be what? P into dA, and element 2 will be what? P plus dP. I am again considering dP. It might come out to be 0, it might not come out to be 0, but I have to make some difference between 2 points. Okay, and one more force which was not there in the earlier case is dm into g, which is the small mass of the fluid particle into g, and this fluid particle is moving with a acceleration of az in the upward direction. So again we'll do the force analysis. We'll do, so summation of all the forces in the z direction by Newton's law of motion, second law of motion, will be A into z. Now this fluid is not static, so we cannot say summation of all the forces in the z direction is equal to 0. So this direction is positive because all the forces in that direction is because acceleration is in that direction. So P into dA, this one, then minus this one, so P plus dP into dA, and this height is dz because it's in the this direction, small height, minus dm into g, and this dm into az. So PdA will get cancelled out, so here minus dP into dA. Let's take this part in this side, so dm is equal to az into az plus g. Again for dm, as in the previous scenario we have written, dm is what? Density into small volume. For small mass there is small volume, E into dA, then again P into dA, rho, small volume is what? Area, small area into small height, this small height, this small area into small height will give us the volume. So az plus g, dA will get cancelled out, so dP will be equal to what? Minus of rho az plus g. Okay. Oh, I was wrong. In the upward direction the pressure decreases here, so this part I said it wrong. In the downward direction pressure increases, rho gh. In the horizontal direction for static fluid the pressure remains same, and in the upward direction it will decrease, minus rho gh. So previously when we solved for previously when we solved for static fluid, we got dP by dz is equal to minus of gamma. Minus of gamma is what? Rho into g. You can see that minus of rho into g is still there, but another thing is coming is az. So now acceleration was in this direction, so we divided it into components for accelerated vessels, az, ax into az, and we did separate analysis on the fluid. dp by dx came out to be minus of ax, rho into ax, and dp by dz in the z direction came out to be minus of rho into this is ax and this is az plus g. Okay, combining the two we'll get dp is equal to the change of pressure is both in the x direction as well as in the y direction, and as we know that for a change of pressure, if pressure is a function of both x and z, then we can write dp is equal to dou p by dou x into dx plus dou p by dou z into dz. This is a differential from. For dp by dx we can write it as rho ax into dx, and dp by dz we can write it as minus rho az in plus g into dz. So dp will be equal to this. This is an important equation. They might ask you to derive this. So let's see the combined effect. So what will happen? Say this is the accelerated vessel. This was the initial when the fluid was at rest. This was the position, but now the fluid has an acceleration in both direction ax and az. Okay, so what will happen? As we know that the fluid will try to remain in the same position, and as a result of which the new surface level will come out to be this. Let us take 2 points here. Let us take point number 1 and point number 2 here, and just see. Say this is the position x1 and this is the position x2. Okay, from free surface level this is the position, say this is z1 and this is z2. So pressure at point P1. Okay, we know that dp, change of pressure between point 1 and point 2, change of pressure between point 1 and 2 will be what? 0, because both are atmospheric pressure, right? यहाँ भी atmospheric pressure लग रहा है, यहाँ भी atmospheric pressure लग रहा है. So dp, in the place of dp we can write a into ax, rho ax into dx minus rho az in plus g into dz equal to 0. Finally what we can write? Okay, minus dz by dx will be equal to what? Will be equal to ax by az plus g. Now see, from point 1, what is dz at point 1? Dz is what? z2. Dz is z2 minus z1, and dx is what? x2 minus x1. This is basically integrating the above. Now we know that z2 is less than z1. From this figure we can easily interpret that. So this minus sign will take it inside, in z2 minus z1 divided by x2 minus x1. This will give us g, right? And we can see, let us bring this out and make it a little bigger. This was 1, this was 2. So okay, this was what? This was x1, this was x2. If I say this is z1, this is z2. So z2 minus z1 is what? This is z2 minus z1, or more like z1 minus z2, and this is how much? x1 minus x2, sorry, x2 minus x1. Okay, if this is theta, then tan of theta is equal to what? Tan of theta is equal to z1 minus z2 divided by x2 minus x1. So in place of z1 minus z2 divided by x2 minus x1, you can easily write tan of theta to ax az plus g. This is what is typically asked in the question. You are to calculate, if this is theta, this is also theta. You are generally asked to calculate, in questions you are generally asked to calculate tan theta. Number 2, they will ask you to calculate whether there will be volume spill out. See, if the acceleration is way too much, this particular section may, this liquid may fall out from the container. So whether there is a spill out or not, volume spill out means पानी गिर गया क्या, या फिर ऐसे भी पूछ सकते हैं कि अगर एक्सेलरेशन ये है, if acceleration in the x direction and acceleration in the z direction is something, say k, then find the volume spill out. So these are the types of questions that may be asked. We will move to the questions now. There are 3 types of problem I will show you, and rest you can practice on your own. Before we move to the problem section, let us see something called as the conservation of volume. If this was the initial position of the container, okay, in the static state, and after accelerated state, this was the initial position of the container. After acceleration, say like the water surface level become like this. Water surface level became like this. So अगर इस तरफ इतना बढ़ गया तो पानी तो कहीं जाएगा नहीं, तो इस तरफ इतना कम हो जाना चाहिए, राइट? Means the volume is conserved. If this is x volume and this is y volume, then x will be equal to what? Y. This is true if there is no volume spill out. So I am not going to write the question, I will just say it in words. So if there is a cubical tank, of dimension I will say height is 10 meters, width is 4 meters, length is 4 meters, and width is given as 3 meters. The water level in the tank is 6 meters. This water level is 6 meters. You are to calculate find the maximum horizontal acceleration, which means they have asked us ax, so that volume of spill out is equal to 0. So we have to be very careful in this question. अगर इस कंटेनर को लेते हैं, सॉल्यूशन में और बोलते हैं कि वॉल्यूम स्पिल आउट नहीं हुआ लेकिन मैक्सिमम एक्सेलरेशन चाहिए, ए एक्स निकालना है मुझे, मैक्स, ठीक है? सो अगर वॉल्यूम स्पिल आउट नहीं होना चाहिए तो इसके एज तक जाएगा पूरा, राइट? अच्छे से बनाता हूँ, इसके एज तक जाएगा, मीन्स द लिक्विड ऑफ दिस लेवल हैज़ टू क्रॉस रीच हाउ मच 4 मीटर ऊपर उठना पड़ेगा. एक्सेलरेशन ऐसा होना चाहिए जिसके वजह से this level of liquid goes 4 meter above and this goes 4 meter below. Width 3, this width 3 means it's in this direction, right? 3 meters. This theta we know. इस थीटा tan थीटा का फॉर्मूला पता है? tan थीटा मैंने बोला था कि जनरली दिस इज द मोस्ट यूज्ड इक्वेशन. ax is there, az is there plus g. Since they have not told us anything about the z direction acceleration, we will consider it to be 0. So ये फॉर्मूला क्या बन जाएगा? tan theta is equal to ax by g. Since az is equal to 0, tan theta को क्या लिख सकते हैं? इस ट्राइंगल को देखो, इस ट्राइंगल को देखो, ये ट्राइंगल, this is 4, this is 4. So tan theta is how much? Tan theta is 4 plus 4 divided by ये वाला, this area, this. So this is 4 again, ax divided by g gives you 2ax by 9.81. ax is equal to 19.62 meter per second square. And this is the maximum acceleration. Maximum क्यों? Maximum acceleration कंडीशन क्या है? वॉल्यूम स्पिल आउट नहीं हुआ, पानी नहीं गिरा. इससे थोड़ा भी ज़्यादा हो जाता तो पानी गिर जाता, इससे थोड़ा भी कम होता तो मैक्सिमम एक्सेलरेशन अटेन नहीं होता. ओके. Second question is, let us go to the second question. Second question, same vessel है. Let us take the same vessel. अभी question थोड़ा change हुआ है. Question is, they have given you the acceleration. Given acceleration in x direction is 21 मीटर पर सेकेंड स्क्वायर. 21 मीटर हो गया. ओके. सो ए जेड दिया नहीं है. दे हैव आस्क्ड अस टू फाइंड आउट वॉल्यूम, फाइंड द वॉल्यूम स्पिल आउट. अब वॉल्यूम स्पिल आउट हो भी सकता है, नहीं भी हो सकता है. यू हैव टू चेक. कैसे चेक करेंगे? लेट अस डायरेक्टली अप्लाई द फॉर्मूला. तो फॉर्मूला अप्लाई करेंगे क्योंकि हमारे पास we know that tan of theta is how much? ax by az plus g. Ax by az plus g, az is 0. So tan of theta is equal to how much? Tan of theta is equal to 21 by 9.81. And tan of theta will then come out to be how much? Tan of theta will come out to be okay, tan of theta we should draw a line. okay, ठीक है. हमें ये पता नहीं है कितना स्पिल आउट हो रहा है कि नहीं हो रहा है. सो दिस इज tan of theta, this we know, right? Tan of theta, this is 4 and this we don't know. so we'll consider वॉल्यूम स्पिल आउट होने के बाद we don't know कि ये कितना नीचे आया, ये पार्ट कितना नीचे आया हमें पता नहीं है. तो ये हम भी ये पता भी नहीं कर सकते. इसको y पकड़ लेते हैं. y by 4, 21 by 9.8. y is equal to how much? y is coming out to be 8.56 मीटर. अब बताओ 8.56 मीटर का आधा कितना होता है? 4.28. हमारे पास जगह ही नहीं था 4.28 जाने का, राइट? ये देखो, ये जब था सो इस लिक्विड के पास ऊपर जाने का जगह कितना था? दिस वॉज 6, दिस वॉज 4 मीटर. और इफ आई यूज दिस फॉर्मूला, ही इज सेइंग दैट दिस y अगर ऐसा बनता है तो दिस y इज कमिंग आउट टू बी हाउ मच? 8.56. उसके आधा करने से यहाँ पे आता है आपका 4.28. मीन्स पानी तो स्पिल आउट हो गया है. ठीक है. तो पानी स्पिल आउट हो गया है, तो हमें अभी क्या करना है, हमें अभी पानी कितना स्पिल आउट हो गया है वो निकालना है। ओके, पानी स्पिल आउट हो गया है, तो इसका मतलब क्या हुआ, ये और नीचे चला गया, ये कितना नीचे चला गया, 4 पॉइंट आपका 28 नीचे चला गया, और यहाँ से पानी निकल गया है। सो अभी मेरा जो करंट स्टैंड सिनेरियो इज लाइक दिस, ये tan थीटा निकला है, एंड दिस tan थीटा इज ड्यू टू व्हाट, एक्सेलरेशन ऑफ 21 मीटर पर सेकेंड स्क्वायर, राइट। सो दिस इज हाउ मच, दिस इज 8.56, है ना, this is 8.56. Initial volume was what, this was 6, this was 10, this was 4, and this side was 3. So initial volume अगर हम कैलकुलेट करते हैं, initial volume of water that was present inside the container was 6 into 4 into 3, that is 72 मीटर क्यूब। और अभी कितना है, अभी इतना है, दिस इज द पार्ट दैट इज देयर इनसाइड द, इसको दो पार्ट में डिवाइड कर सकते हैं, दिस पार्ट एंड दिस पार्ट, राइट। है कि नहीं, so या फिर वी कैन से दैट ओके, या फिर और एक वे है, वी नो दैट ओके दिस इज द स्ट्रक्चर ऑफ द फाइनल फॉर्म, इसमें लिक्विड है, इसमें लिक्विड नहीं है, वी नो दैट्स दिस डायमेंशन 10, दिस 4 and this is 3. If from this total dimension final means 10 into 4 into 3, if I remove this particular triangle, this triangle, then I'll get the final volume. So I'll remove this triangle. How to remove this triangle? This is, what is the volume of this triangle? This volume of this triangle is half this base is how much, 4, half into base into altitude, this altitude is how much, 8.56. This gives us the area into 3, this will come out to be 68.64 meter cube, and thus the volume spill out will be how much, will be 72 minus 68.64, which will give us 3.36 meter cube. One question for you. So one question for you to practice. This is a typical question. You have to take the help of the book. So if they say that okay, same my dimension, same question, the height of the container was 10 meters, the volume of water was or the height of water in it was 6 meter, width length of the container was 4 meters and width was 3 meters. And same question, if ax means this x direction, this is z direction, if ax is equal to 29 meter per second square, then find the volume spill out. In this question, if you calculate, you will see that in this question, when you calculate, you will see that this height it has crossed. In the previous question it was here, it has crossed like this, so you have to make some this x part is also changing. This 4 will no longer remain 4, it will be decreased, so you have to apply your mind and solve the question. I will not solve it for you. This is a typical exercise so that you open your books and try to study by yourself. So thank you guys. I hope you understand. You could ask me questions afterwards if you don't understand anything. Thank you.